I'm Daniel Nicoletti, and I work for KDOW. In this tutorial series, we are going to be writing a mobile chat application. This chat application is going to exchange messages and also have push notifications. For the push notifications, we are going to be using Firebase, but not on the part 1, that you will want part 2. But first, we need to create the chat applications. For storing messages, we are going to be using Postgres. For creating the user interface, we are going to be using Qt with QML. And for the backend, we are also going to be using Qt, but with QtList. QtList will then store messages on the database, retrieve messages, send messages to the chat applications, and also send push notifications to Firebase. So we are going to start with the backend. We are going to create endpoints. We are going to create a WebSocket connection, and we are going to talk to the database. Here you can bootstrap your backend application. Then we can make sure it works by compiling it. And okay. Now we can test if it runs. And there you go. You have your application running. Final test is to issue a browser and make sure it can talk to it. And there you go. Now we have a working application. Of course, the application has been previously written, so we are going to switch to Qt Creator and walk through the code. So there we have the project. Our project is going to need to find QtList, also going to find ASQL, which is a asynchronous SQL library, which you can also take a look at another video explaining its feature and its usage. And we are going to take a look at the database that we are going to use in this project. So this database is going to create a users table where you have the one-up script. It's going to create the table. If you want to roll back your database, you have a down script. So this script is run by ASQL, and it can do the database maintenance easier for you. So we create a user database, which has an ID, which has a nickname for your user, and also has some extra information like Firebase tokens and stuff like that that we are going to be needing for the next part of the tutorial. We also are going to be using a message table, which will have a created field so that you know when the message arrived. You know the user ID, so we know the user who sent the message, and also the message text itself. If you are going to roll back your database, you drop the table. Then we are going to have a function, a database function, to make it easier for the real-time communication. Postgre has a feature to notify its clients. It's IPC, inter-process communication feature that makes Postgre really well suited for this project. So this channel is going to be called with some text, and this text is going to be a JSON. So on the backend, we are going to be listening for new message topics, and everyone listening to this topic is going to receive this JSON. And this JSON, as you can see, has the ID of the message, has the nickname of the user, and also when the message was created. This trigger is going to be run every time a message is inserted on the message table. So you create a message, the database automatically send the notification to the backend server. The backend server then is going to forward to the messaging mobile application. And that's it for the database and for the simple application. As you can see, we don't have any passwords and nothing fancy here. It's up to you. The important part is to show how to create new messages, how to notify the users, and then how to add Firebase to your project so you can send a push notification with the message text. Now let's take a look at the code. The code here has the main application here. The main application is going to launch the root controller, and this is going to register the endpoints that the controller is going to have. And we also have here a connection to a chat database. So you need to create a chat database on your machine. So to create a new database, an easy way is to have a user with your own name. This user is going to have the ability to create new databases. So you're going to run this code and already have a user's Daniel with this ability. Then you can just go ahead and create database with the name that you want, like chat app, for example. And now you have a chat app application. You can then connect to chat app database, and there you have it. You don't need to worry about password as well. That's on your development environment. Back to the code. We have the connection here made to the chat database. This is the database already filled with information. So now we are going to take a look at how the controller looks like. The controller root is going to be at the empty namespace, meaning we are going to be at the root URL, and we are going to have a user's endpoint that has the REST action class, meaning that when there is a post to the users, this method, then this method is called. If it's a put, then there is this method and this method called. The same thing is going to be for the messages. When the user send something, some HTTP request for the message endpoint, and it's a post, this method is called. If it's not a post, if it's a get, like on the users, it will receive a bad response because the method is not registered here. We're also going to have a WebSocket, and this WebSocket is going to make sure our user is connected and we can send, hey, there's a new message in real time. And here we are going to have all the clients connected on a hash. So when a new message arrives, we can take a look at the connected clients and send a message. If the client is not connected, for example, we can just go ahead and send a push notification to the user, or send or ignore the message. So going to the implementation, this is the user's post endpoint. So the user is going to make a post request, send in JSON data. We are going to get this JSON data and create a new user on the users table. We are going to get the JSON nick and store as the nickname of the user. And we are also going to store the JSON object on the JSON data type. because Postgre has a JSON object data type, we can just store it here. We are going to take a look if we got a response. The response is the new user ID, and we are going to send the new user ID back to the client. So we get the first column because it's just ID, get an int, and send it as a JSON to the mobile application. We're not going to create a password because this is just a tutorial, a simple tutorial, and this is not the main focus of the tutorial. So of course, don't do this on your own applications. Well, the user might change his nick or might want to change some data. So we also have a put method to update the user's information. The put method is very similar to the post method. We just go ahead, get the JSON object, and we set a nick and set a new data coming from this information. The big difference here is that there is a data user ID that we need on the where part. We don't really need to send anything back to the client, but we just don't send an error message and also don't set an error status on this request. So here, this is Qt list, making sure this request is not sent when the method is finished. So this async class makes sure that when it is still alive, because it's captured here, it's not going to finish this request. Here we get a new connection from the database, execute the function. Here we have the parameters, and here we have the callback that is set when we have a response for the database. We could use WebSocket also for sending messages, but we are just going to go ahead and create a post method here for simplicity. Again, this is very similar to the other methods, where we just grab the JSON data that the client sent, we grab the message field, and we insert in the message table. So the JSON object data has the user ID of the mobile user, and also has a message, which we explicit extracted here before. And we just go ahead and insert into this message and return the ID of the message. We return the ID of the message so that the client mobile application can filter when it receives a new message notification. So on the rest of this code, it's pretty much the same. We just go ahead and send the new message ID, or if there is a database error, we send an error message. And now we are going to talk about the WebSocket. WebSocket part is very simple. It's going to make the HTTP upgrade handshake. And after that, it's going to store the user's connections and know which user this connection belongs to. So when a new notification from the database arrives, it can go ahead and talk directly to the client in real time. So here we have the WebSocket method. The WebSocket method is going to take the user ID as part of the URL, just to make it easier for us. We are going to do an HTTP handshake. Then we are going to make sure the user is not already connected to the server. So we get the user ID, we convert it to an int because on the database it's an int. And then if the user is already connected on our list, we close the connection and say, you're already logged in. Then, if this doesn't happen, we are going to insert on our hash. Remember, this hash has an int for the user ID, and the context object, because the context object is what tracks the connection. If the client closes the connection, the context object is destroyed. So here we insert on this hash table, and we connect to the destroyed signal of the context object to remove the user. So when the connection is closed, we can make sure the client can connect again. Below we have a database query to fetch all the messages, doing a join with the users table to also fetch the nickname of the user. Once we have all the messages, what we are going to do, we are going to send as a text message, because WebSockets accept binary and UTF messages, and we're just going to send the JSON object here. So results.json array is a feature of SQL that converts all the response here into a JSON array. So we just go ahead and create a QJSON document to serialize that and send to the client. After this line, the connection is not closed because it's a WebSocket connection. So we need to have a pointer to the context object to send information to the user. And how can we send information to the user? Here on post fork, this happens after the Qt-List application forks or starts if there's no forking involved. It's going to grab a connection to PostScript and create a subscription to that new message topic that we created, that we are going to be calling on that trigger. So whenever the database receives this notification, this lambda here is going to be called. So you get a new message, this lambda is called. Then what we do, we iterate over all our clients, and we go ahead and send the payload, which was already a JSON. So the notification JSON toString, and all our clients is going to receive whenever a new message arrives. It's very, very important to track connection states, because the database might need to restart or there might be a network problem. So when the state changes, we go ahead and do another subscription. So it's connected, we subscribe. If the connection is disconnected, we go ahead and disconnect our clients. We disconnect our clients because we are not going to be receiving notifications for this database anymore. So we need to make sure after that we open again the connection. And here we just have those blank methods created on when bootstrapping. You can leave it there so that you can test on a browser. So now when we start our backend, we can see the methods that were created. We have the internal methods here, post, put, and post, and we have the external paths where we have messages, users, and the one for WebSocket. Now let's take a look at the client application. So this is the client application, the one that's going to be running on Android. On this first part, you don't need to have Android environment configured, because it can work well on the desktop. But for the push notifications, running on Android is mandatory. So what do we have? We have a main application. This main application here is going to have a drawer to have a button to edit the new user. and it's going to push the user configuration users. There's also base message, which is going to be listening all the messages. And if the user ID is not set, then this is going to show the page users first for the creation of a new user. Here we also have the settings, where we have an user ID, a server, a nick, and the full name of the user. And this information is going to be used on page user. Our page user is a simple page that if the user ID is still 0, we're going to say that the title is create user, else update user. Server and port. This is, of course, for making it easier. We are going to say localhost port. And here we have the nick and the full name of the user. When the user click on the create button or update button, then we have this JavaScript code which creates a JSON object and send the JSON object to our server. So we create this request. If we are going to create a new user, it's going to be a post, else it's going to be a put. Then we set the HTTP URL, and we have the server, which is the server from the server field, /user. So we post or put on our localhost users. We set the content type to make sure it's application JSON and the server understands it properly. And we say send the JSON object. Here we send settings.userid. It's going to be 0 if it's a new user. Then a nick, full name, and Firebase token, which is going to be added later. We got the response. We are going to parse the response when the server sends it. If the status is not 200, then what we are going to do is say, put on the console, there was an error. You probably want to create a dialog message. When the status is okay, then what we do is get the ID from the JSON and store it on the user settings. The other fields, we are going to be using the ones from here, and also make sure it's on the settings file. So this is the page messages, where the users can see all the messages and send new messages. To be able to receive messages in real time, we are going to be using WebSocket. So the WebSocket, once the connection is established, will send all the messages to the mobile application. And when a new message arrives on the server, the message is immediately is shown in real time to the user. So when text message is received, we are going to parse the JSON message. And if it's an array, to make sure we can do it properly, we are going to go and insert on the messages list model. So each element of the JSON array is going to be inserted. If it's not a JSON array, meaning that it's just a new message, then we are going to insert the message right away. We also have a timer here. So if the connection is not open, then it's going to try to connect again. If the connection drops for any reason. And here we have our layout, where we have a delegate for each message. We also have a toolbar on the bottom, which is only enabled to when the WebSocket connection is open. And it's only enabled because the user won't be able to send new messages without the connection being open. When the connection is established, we have a text field, so the user type the message, and when they click or accept, we're going to call this method. This method is going to send a message for the server, and we are going to have the message shown here because the message is going to go on this post and be received by the WebSocket. So we are going to be testing both things at the same time. Basically here, we just do a post to our setting server on the message, make sure the content type is right, send the user ID so that the server knows who sent the message, and we send the message text. Okay, let's launch our new application and test with the backend server. As you can see here, we can specify the server. We can set our super nickname and our full user. And there we have it, the message page. Here we can say send a new message, some message, and there you have it, a new message. This new message came through WebSocket, and this message was sent through HTTP REST API. Another message, and as you can see, we are going to close the application and launch again, and there you have all your old messages because they were stored on the database. Well, I hope you find this tutorial useful, and if you like and want to have also push notification on it, take a look on part 2. Bye!